So interest points, the idea is, again, that was like a very, very crude definition of interest points. We will try to formalize that in a next couple of slides. But what we want is we want to detect such interest points in your input images. Okay, so we want to detect all these interest points. We don't want to miss anything. If you want to represent your image well using some set of features, we should not detect like any false interest points. For example, if location is boring, we don't care about that boring location. These should be well localized, which means we should exactly know where that interest point is. Okay, and these interest points should be robust against any kind of noise you might have in your input image. And this property you have seen like when you're trying to do edge detection as well. And of course, it should be like efficient to detect these interest points. We can't take like years or centuries or decades to detect these. Even minutes, I think it's computationally expensive. Okay, so one possible approach is corner detection. What we can do is, if we just try to detect corners in your image, they can be represented as interest points. And what we do is we try to make use of image derivatives. I think now you are well familiar with how to compute image derivatives and what they represent. So we'll try to make use of those. And we'll also try to extract like this boundary to be able to do corner detection. Okay, so let's try to understand like some of the key properties which we want when we perform these key point extraction. Now we have this object. So we have image number 1 on the left, and we have image number 2 on the right. So you can clearly see these like correspond to the same object. Okay, it's just like rotated. The scale is slightly bigger. Now the first property I think which we discussed was repeatable. We want these key points to be extracted exactly the same way like it was done in the first round. So it should not change. Okay, and we want these points to be distinctive. And so that's one key property of these key points. Because if you choose like these dark regions here as key points, then it's kind of not distinctive. There are a lot of these dark regions and you cannot really tell, okay, which one is which. So here I'm showing you some key points which are present in this image on the left and the corresponding key points on the right. Okay. So if your algorithm can actually detect these key points in this image, and it's like able to repeat the same thing on a different set of a different image, which is again of the same object, and it can identify the same set of key points, then you can use those key points to actually perform image matching, right? Because those key points, if they are matching, then you say, okay, it's the same image, even though the image is rotated. Right, so let's try to understand how we can actually use these key points for key point matching. First step, it's fine, you detect these key points. So don't worry about how these were detected. We'll cover some algorithms for that. For now, just assume that, okay, we have an algorithm which can do this. So we detect key points in the first image, we detect key points in the second image, and these crosses are actually showing you those. Then the second point is you will define some kind of region around this key point. In this case, this is the window shown by the yellow bounding box. And you will do the same over here. And you can see that the bounding box on this image is actually slightly smaller than bounding box on the right. Okay, so then the idea is when you are detecting these key points, you should be also able to tell the scale of that key point, how big that key point is, so that your algorithm is actually scale invariant. Okay, if you enlarge your image or you have a bigger object, which is the same object, then you should be able to match these key points. Okay, so then what you do is you extract features from this patch. So let's say if you just focus on this, it will look something like this, right? And if you extract from this location, it will look something like this because it's slightly bigger. The scale was different. And the third thing which you will need is some kind of a rotation variable, which will tell you, okay, what is the orientation of this object? And you will use that orientation to fix the alignment of this patch. Okay, so you rotate that, and now you can see that, okay, these patches look exactly the same, which means that these two different key points are actually same part or same key point in your input image. Okay. And the final step is you extract some kind of features from this patch, and you try to match those. So this is kind of, you can say, like region-based features, because you're not using the whole image. You're only using this small region over here. And if they match, then you say that, okay, key points coming from the same image. And similarly, you can do for all the other key points. And if all the key points match, you can say that, okay, these two images belong to the same object. Okay, so that's how, like, one simple, interesting application, how you can, if you have an algorithm which can detect these key points, how you can utilize those key points for image matching. So on a large scale, I mean, it doesn't work this way, but if you think about this, these days you have image search, right? So this algorithm can even be used for that image search, whether it's like Google image search or Bing image search. You will give like your input image, which could be this image, and then that algorithm on the backend will detect these key points on your provided image, and it will do the same for all the images like which we have in like Bing server or Google server, which will give these kind of key points, and you will follow this exact same set of steps. And then what will happen is the images which are actually very close to each other, based on these features, your Google search engine or Bing search engine will retrieve those images or show you those images. Okay.